Welcome back to our series on introductory statistics. I'm Mark Ledbetter. This is lecture video 19, part G. We are in part 7 of chapter 5, and really this is going to be just a little bit of section 3 in part 5. Section 3 is called counting or enumeration, and it's nice to know, but in a 3-credit hour course, we just don't have time to cover every single section in the book. And this is more of a section for those people who are going to become data scientists or statisticians, I think, rather than a general education type of thing. All right. So we're just going to learn a little bit. So here are all the things we've learned so far. Last time we talked about the addition rule in detail. And what we have left to do is learn about permutations and combinations. So that's what we're going to do. So what is a permutation? It's different orders of things. So I'm going to give you an example here of 1, 2, 3, 4. So I have 4 numbers, 1, 2, 3, 4. And so what I can do, so here is the strategy I use to keep this straight. I'm going to keep 1 the same. And I'm also going to try, at first I'm going to keep 2 the same, and then I'm going to switch these last 2 numbers, okay? So I'll end up with 4 and 3. Well, all right. I can still keep 1 the same, but now I'm going to put 3 here. So I'm going up 1. And then I can put 2 and, 4. Now I'm going to keep 1 and 3 the same. And I'm going to switch these 2, so I have 4 and 2. That's all I can do with 3. So now I'm going to switch to 4 in the second spot. And you notice that each case there's 2 and 2. So it makes sense that there's going to be another 2 for 4. So then I have 2 and 3. And switching those would be 3 and 2. Now, I've gone through the second position here has gone through 2, 3, and 4. That's all the numbers we have that are above 1. So now I have to switch the first number, and I'm going to increase it to 2. Now notice that I have 6 different permutations. Each one of these is a permutation. And so they're different orders of the numbers. So this is 1, 2, 3, 4. Here's 1, 2, 4, 3, etc. So each of these, that's what a permutation is, how to arrange all these things. Okay? The unique ordering of these objects. So I could do the same thing with 2. I would start with the lowest number here, and then the lowest next number would be 3, and then 4. Okay, so 1, 3, 4. I'm going to keep 2 there, and then I'm going to try to keep 1 there, and so 4 and 3. And then we just keep going. Okay? We'll figure out how many are in this a much easier way than listing them all out. Okay? So the formula for permutations is called a factorial. Okay? So you should use the right terminology. It uses an exclamation point, but don't say in exclamation point. That's not how we say it. This is in factorial. Exclamation point just means that we're excited about in. In! Yes! In! But that is not what we're really doing here, okay? So we're not rooting for a team or something like that. So anyway, this is in factorial. And the definition is n times. This is all multiplication. So we're multiplying. Okay, so it's multiplication. We'll take n, and then we subtract 1 value from it, so 1 less than n, and then 2, and we keep on going until we get to 2 times 1. You do not go to 0, because if you put a 0 out there, 0 times all of this will be 0. So we stop at 1. okay? So whatever n is, we start there, that's the largest value, then we move down a number and keep moving down a number until we get to 1, and then we stop and then we multiply. So so the factorial of the number n is the product or multiplication of all the whole numbers from 1 to up to itself n. So let's do a quick example. How many different ways can the following animals that need to see a veterinarian be permuted? So what we have is we have 1, 2, 3, 4, 5, 6, 7. We have n equals 7 animals. And if we were to want to know all the different possible orders of these 7 animals that could occur, then we need to take 7 factorial. So 7 factorial, we start with 7. Then we subtract 1. This is 6, then 5, then 4, then 3, then 2, then 1. Okay. So this is going to be a big number. And I don't remember if this calculator that I have has the factorial button on there. But 7 times 6 times 5 times 4 times 3 times 2 times 1 is going to equal 5,040. So that's a lot of different orders of these 7 animals. Now let's go back to our example up here where we had n equals 4. So n factorial is equal to 4 factorial, which is 4 times 3 times 2 times 1. 4 times 3 is 12 times 2. There's 24 ways that we could order these that are unique. So now I had 6 for 1. It makes sense that I'd have 6 for 2, 6 for 3, and 6 for 4. That's 6 times 4 is 24. So that's exactly what we have here. Okay. So unfortunately, we have this nice formula and definition, but then we run into a problem. There's an exception. We need to know what the value for 0 factorial is. We need to know this because we're going to use it in the next chapter when we talk about the binomial distribution. There will be times when we're dividing by 0 factorial. So when I ask students, what do you think 0 factorial is equal to? Most of them say 0, but it can't be 0 or else we're dividing by 0, which is not allowed. So especially when we're calculating probabilities, because the result has to be between 0 and 1. If I divide by 0, I'm either getting undefined or positive infinity or negative infinity, depending on the top. Well, in probability, it'd have to be positive infinity. We don't have negatives for probability. So that's impossible. The probability has to be between 0 and 1. It can't be infinity. So we need a good definition. We cannot use the definition that we had earlier because it gives us a contradiction. We're supposed to start with n. Well, n is 0, and we're supposed to subtract and keep going down until we get to 1. But if I subtract 1, this is negative 1, and then I'd have negative 2. I'd never get here. I can't get, as an old joke used to say, you just can't get there from here. Okay? And if I start with 0, and multiply all these things, I'm going to end up with 0. And I just said we can't have that as the definition. So somebody who is clever said, well, let's think about what we are doing here. We're ordering things. And how many different ways can you order 0 objects? Some people would say none, but this person said just 1 because there's nothing to order. There's nothing in there. There's only one way you can order nothing. So, okay, but there's some problems with that too, right? So here is the definition. We've defined 0 factorial to be equal to 1. And I just said why. What does it even mean? And the logic is that, again, that you can order 0 or no objects in just one way. Like I said, there's some problems with this as well, but we need we need to have 0 factorial defined as a finite value in order for many of the calculations we're going to use in statistics to work out correctly. And like I said, we'll see this in the next chapter with the binomial distribution. Okay, so that is permutations. Okay, so factorials. Well, what about combinations? So we want to count the number of combinations of things. Here, we don't care about order. So the different orders are considered the same. This formula involves several factorials. So let's talk about it. Combinations are the different ways that we can select a group of R items out of a total number of N items where we don't care about the order. The order does not matter. We just care that we're selecting those R items and how many different groupings of those can we have. So here is the notation that the book uses. It's different notation than I've seen in most textbooks, but we can use it. It's just fine. So you'll have the combination of R items or N items chosen R at a time. So let me write this out. The combinations, so what this notation is saying, it's the number of combinations of N items chosen R at a time. So we sometimes say N choose R items. That's sometimes how we say this, okay, how we pronounce it. It's the combinations of N choose R items, or how to choose R, how many different ways can we choose R items out of N total items, okay? Well, you can see that we've got factorials, 3 factorials, and depending on what the numbers are, they can be really large, and sometimes your calculator won't handle these numbers because it only has, say, 8 or 10 decimal places. Let's see, this calculator, this one has a lot. So I have So this one actually has 14 decimal places. My other one only has like 8. And when it doesn't have enough decimal places, then it goes to scientific notation, but it may end up rounding off values so that you don't have an exact value. So we need to learn how to cancel out some of these factorials so that we can end up with the exact answer and we don't have an error. So let's look back at our example with the vet. And it's towards the end of the day, and 7 owners with these 7 different animals have walked in, and the vet says, I'm only going to be able to see 3 of these people before it's quitting time. So how many different combinations of 3 of these animals out of 7 is there? Just out of curiosity. So this is going to be C, 7, 3. And that's going to be the first numbers. This is N and this is R. So looking at our formula up here, we have N factorial on the top. So this is going to be 7. So I'm going to write out the formula first. And I'm going to say N factorial over R factorial and N minus R factorial. Now I can fill in the values, and it's less likely that I'm going to make a mistake. So this is going to be 7 factorial over 3 factorial and 7 minus 3 factorial. This is going to be 7 factorial, 3 factorial, 4 factorial. Notice that the two numbers on the bottom have to add up to the number on the top. Okay, that's always true. So now I'm going to simply write out the definition of these. So this is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. I write out 3 factorial, 3 times 2 times 1. 4 factorial, 4 times 3 times 2 times 1. I'm going to use the largest factorial here to cancel out the most numbers out of the numerator first. So I can put parentheses around these, and then those are gone. Okay? And so then I'm left with 7 times 6 times 5 over 3 times 2 times 1. Well, this is 6. So I can cancel that out, and I'm left with 7 times 5, which is equal to 35. So there's 35 different ways that 3 of these animals out of the 7 can be chosen. 3 at a time, if you will. Okay. So here's an example. So with this 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1 was simply, 5,040. But let's find this. This is going to be n factorial, r factorial, n minus r factorial. This is going to be 15 factorial over 10 factorial times 15 minus 10, which is 5 factorial. So I've got 15 factorial, 10 factorial, 5 factorial. So I'm going to get my scientific calculator out and see if it gives me 15 factorial. 15 math, and then over to the factorial. And here is what it gives me. For 15 factorial, my calculator says it's equal to 1.30767436 times 10 to the 12th. Okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've only got 9 decimal places, or actually, if I count this one, 10. So I have a total of 10 decimal places. So the tens and ones, the last two numbers, so we'd have 13076743668. Okay, so I'm sorry, there's going to be 10 decimals out of 13 here. So, because it's 10 to the 12th. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The hundreds, the tens, and the ones. So 100, tens, and ones have all been rounded to 0 or cut off. The calculator doesn't keep those, it doesn't have enough space for those numbers. Okay? So that's the reason that we need to cancel out, because if you don't, you're not going to get the right answer. Now, what you can do is put all of this in your calculator at the same time. My calculator will handle it if I put, actually there's a button on my calculator for combination, so I can say 15 choose 10, and it can calculate that in the same way we're going to do it, which is to cancel out things. So I've got 15 times 14 times 13 times 12 times 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now I have 10 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I can cancel all of these here out. And I also have 5 times 4 times 3 times 2 times 1. So I have 5 and 3 is 15. So I can cancel out 15. And then I have 4 and 2. No, that's 8. So I can't do that. I've already canceled out 8. So 4 will go into 12 3 times. And 2 will go into 14 7 times. And so I don't have any numbers left on the bottom. I have 7 times 13 times 3 times 11. And this is going to be 7 times 13 times 3 times 11, which tells me it's 436. I'm going to check and make sure that I did it right. I'm going to say 15 math, and then N choose R 10. Oops, I did something wrong. I canceled out too many somehow. 15 choose 10. It says it's 3003. Okay. So I've got those. I've got 5 goes into 5 times 3 is 15, so that goes away. 4 goes into 12 3 times, so that goes away. And then 2 goes into 14 7. 7 goes in, so 14 divided by 2 is 7. 12 divided by 4 is 3. And did I forget my, no, I got my, so I got 7, 13, 3, and 11. 7, 13. Oh, I must not have multiplied one of the numbers. So this is 3003. Okay. So that's how we calculate permutations or factorials and how we calculate combinations. So we're going to use those in the next chapter. So I wanted to give you an introduction in this chapter so that it won't be the first time you see it when we get to the binomial. Please make sure you update your formula sheet. Remember, that's your formula sheet. You can put what you need on there so that you can understand the formulas and use them correctly. If you have questions about the course content, please ask. I'm happy to help you. You can come to office hours, and I am always happy to help you, or we can stay a few minutes after class and I can help you then this semester. Please take care of yourself. Stay safe, because we want to see you here next time.